primary axis. And that's going to be true whether it's mirrors, and it's going to be especially true, important when you do mirrors. It's also going to be true with lenses. So you can always take one and shift it and draw it right through the center of the vertical line of the lens and the horizontal line that represents that optical axis. So you can always have that one. Now, with this one, it's tough to draw, but there's also a dashed line coming back along that same line. So it's going to hit, and then it's basically part of that's going to get refracted back. So now you've got another one that's going to come in, and it's going to try and go through that focal length. So this one's going to hit, if you draw that parallel, it's going to go up. But part of that's going to come back, and it's going to go try and go through that focal length that's back behind it. So right away, even if I just have those two, that's going to tell me, I have a pretty good idea of where that image is going to be. So based upon these two lines, is the image going to be upright or inverted? It's going to be upright, and it's going to be small, tiny. Virtual. And it's going to be virtual. So right away, what should I know the sign on my magnification should be? Positive. My magnification should be less than 1. Yes, it's tiny.
How do we know it's tiny?
Because this is my object right there.
That's what I heard.
Okay? That's my object.
Yeah.
So that's my image. Okay? And so that's small.
Okay.
Okay? Now, so we're going to do the math. So because of the fact that I've given you the focal length is 40, and I've given you the object distance is 20. So I'm going to try and find the image distance. So I've got 1 over psi is going to equal 1 over f minus 1 over so. Now, is my focal length, which is 40, going to be a positive or negative number?
Negative.
Oh, it's a negative number. Why?
Because they're going out.
It's going out.
Gotcha.
Okay, it's a negative person. It's going to spread things apart. Okay, or diverge people. So this is going to be 1 over negative 40 minus 1 over 20, and then take the inverse of that. So what do you get for your image distance? Negative 13.3 centimeters. Now, does that make sense in terms of your image distance?
The image is going to go back.
Yes.
So here's the story. So here's your object distance. Okay? That was 20. Does it make sense that my image distance is 13.3?
Yeah.
Because my image is inside of the object. Okay? So here's my object. My image distance is inside it. This is why yesterday, when I had you all stand up and look, and you looked in front of it, you looked in front of it to see that image. Yes, Olivia?
How come the 40 is negative?
Because this is a concave lens. And when that light hits, it spreads out.
Oh.
But if it was a convex lens bring lights together.
Oh, negative. Okay.
Okay, thanks.
Spread apart, positive.
Is it above one or
Okay.
below one? Or is it positive?
Makes sense?
Which-
Yeah.
which
Okay.
one?
Yes?
What do you
Yeah.
think?
Okay,
Focal
wait.
length is negative.
Huh?
Focal length is negative?
Yes. Because on this one, that focal length is negative because it spreads that light apart.
Oh,
The other, so like image distance.
That has, all right. So here's the rule. Your object distance is always positive. There's no exceptions to that rule. Your focal length can be positive or negative depending upon what the light is doing. Okay? But then that drives what happens to the sine of your image distance. So your image distance is dependent upon what happened. So what's set in stone is your object distance is always positive.
Okay.
Your focal length could be positive or negative depending upon what the light does.
And it's direction.
Your image distance, okay, that could be positive or negative based upon the math over here. Okay? Now, here's another trend that I want you to see. This takes a little bit of leap of faith of imagination. Just a little. Not much. Okay. So we're going to go back up here to where we had that first convex lens. Okay? On this one, we had a positive object and positive image distance. So my image distance here was a positive value. So here's what I want you to see. And this is, it takes a little bit of imagination. But on this one, what you see is in the same direction that the light is traveling. Okay? So if that image is in the same direction that the light is traveling, your image distance will be a positive value. Okay? So this light's coming in like this, and I'm making that image there. That's in the same direction that the light is going. Okay? Now, the one that flipped you all out and you wanted to burn me at the stake, okay? This one, let me go back to that. Okay? Hold on. Okay?
Get it now.
That one where you wanted to burn me at the stake? Because there was a witch. Notice with this one, this image here is in the opposite direction that the light is going. So the light is still going in this direction. That's the primary path of the light. But what you're seeing is that part of that light that gets refracted back in the opposite direction. So the light is still going here, but you're going to create an image back over here that's in the opposite direction that that light is going. Notice that this produced a negative value for SI. Okay? Now, if you go to this one, okay, where you have a concave lens, notice this one, the light is still going through the lens this way, but the image is in the opposite direction that that light is trying to go. This one still produced a negative SI. So if you have a negative value for your image distance, that means that what you're seeing is in the opposite direction that the light is going. And that's going to play out with lenses and mirrors. Okay? But that's why I said this takes a little bit of creativity, because you think, okay, great, the light's actually going this way, but I'm seeing an image over here that's in the opposite direction the light is going. It's like, what do you mean? If the light's going that way, how can you make an image? Because part of that light, okay, is getting refracted back and forming that image. That's why it's a virtual image. Yes?
Does that always happen whenever it's like inside of the focal length?
No. With this, it does. Okay? But that's not an absolute. Okay? Now, here's the other thing. Notice that this is showing dashed lines. So dashed lines indicate that that's light that's coming back in the opposite direction. And we use that same system like on drawings. So dashed lines are light that's in the opposite direction of where that thing is going. Shannon?
Whenever the side is negative, it's virtual.
No.
No.
Okay? Well, hold on to that thought. Hold on to that thought. Okay, so now you go back to the math of this one. So I've got a psi of negative 13.3. So if you look at your magnification, so your magnification is going to be negative psi. So I'm going to have a negative of negative 13.3 divided by 20 centimeters. So right away, what do you know about your magnification?
Tiny.
It's going to be a positive value and less than 1. Because I'm taking negative of the negative 13.3 and dividing that by 20. So what do you get for your magnification?
0.665.
So 0.67. So that's a positive value less than,
One.
so that's why, look what happens. You've got a positive value for your magnification, you're producing an upright image, and it looks small. So that's why yesterday, when I showed you that floating floor, and I said it's really, really tough to see, that's why. But that's also why it was small, because you had a magnification less than 1. But it was upright because we had an image distance that was a negative value. Okay? But it was in the opposite direction of that light. So if you look at that one we did yesterday, so here's that light source way up here, and I had that lens down here, and you all looked and you saw that tiny floating 4 right there. Okay, that's why. So it was a virtual image, okay, created by that light that was actually getting spread out.
Someone's coming back.
But part of that came back. That was like that hologram video, almost like a hologram that I showed you at the beginning. Okay, so it looks like it's floating. But if I tried to put a screen in there, why wouldn't that work? Number one, it would block it. Okay, because if you try and project it onto the screen, well, that's cool, great. You just block the light from hitting the lens. It'll be tough to do. Okay, so stop you on the camera. Stand up.